So today we are going to see the topic that it's called either solving for a variable or isolate the variable. Those are relative terms. They are used as synonyms. Solving for a variable or isolating the variable, it's the same. How do we call or what is isolate the variable? It's a process in which in a literal equation, that means that has letters, we isolate a specific variable in the first member of the equation and all the other terms in the second member of the equation. So the idea is that when isolate, it's to left alone in a specific variable and a specific letter in the first member and the other terms in the second member of an equation. We need to remember for this specific topic that for moving a term from one member to another, we need to use the opposite mathematical operation. So that means if we got something that it's in an addition, we will send it as a subtraction. If something is in a subtraction, we will send it in an addition if we are moving from one term to another or from from one member to another of the equation. If something is multiplying, to the other side it will go dividing, or if something is dividing, it will go multiplying. If we have a specific root, it will move to the other part of the equation as a power. So if we got a square root, it will move as a power of 2. If we have, I don't know, a power of 3, it will move to the other side as a cubic root, and etc. If we have a root number 7, it will move to the other side as a power of 7. In this case, we need to start for the isolation part, we need to start with the terms that are farthest from the variable. We are isolating at the end those that are close to it. That's very important. So it's very important as we were talking about. Let's see an example first. How to isolate a from the next formula. M equals 1/4 of a squared t minus 2b. So first, we are going to start what is farthest to the term we need to isolate, in this case a squared t divided by 4. We can start with this one that doesn't have a, and it's super simple for moving it from this member of the equation to the other. The minus 2b, it's in an subtraction here, so we can send it as an addition to the other side, and it's going to be m plus 2b equals 1/4 of a squared t. After that, maybe we can remember a little bit about the um, specific linear equations that are fractionary. If we have a fraction, maybe if you don't want to work with fractions, we can multiply all the equation by the least common multiple, in this case 4, in order to make it a whole equation with no fraction. So it's going to be 4m plus 8b. The other term, the one that it's going to write, is going to be 4 divided by 4, it's 1. So it's going to be a squared t. After that, we can send the t that it's multiplying the a squared, the t it's multiplying the a squared, it's going to be, or it's going to go to the other side dividing, so it's going to be 4m plus 8b over t equals a squared. The next thing, we need to get rid of the part of a squared. In this case, remember, a power goes to the other side as a specific root, in this case the square root. So it's going to be the square root of 4m plus 8b equals t divided by t, equals a. In this case, remember, for the answers it's more normal to put the variable equals our answer than answer equals the variable. So in this case, we can put it like a equals the square root of 4m plus 8b divided over t. Sometimes in some books you will see a process that is called rationalization, that it's getting out or that you cannot have roots on the denominator. Since we haven't seen that topic, rationalization, we can left it like it is, this kind of answer. So for this kind of exercise, since we are not going to see rationalization until some weeks, in this case, we can left the answer like this, and this is going to be the answer because we have isolated the A. Remember, the idea or the important part today is we need to isolate the letter. So if in the other side of the equation we have roots in the denominator, it doesn't matter. If we have something that can be simplified, maybe it's also correct, because the idea today it's only to isolate, left alone, a variable in the first member and all the other terms in the second member of the equation. Let's see another example. Imagine we have this specific formula, 4 over c minus 2 over b equals 6 over a. Remember, if we have fractions, maybe if you don't want to work with fractions, we can multiply by the least common multiple. So in this exercise, the least common multiple is ABC. So we will multiply all the equation by ABC. And let's see, if we multiply the first term, the first member is going to be A, B, C divided by this one. C and C gets eliminated, and it's going to be 4AB minus, on the second one, it's going to be, if we compare these to ABC, B and V will be eliminated, and we will get 2AC equals, the other one is going to be 6. The A and A gets eliminated, so it's going to be 6BC. Then we need to have the B's in the left, what doesn't have B on the right. So it's going to be 4AB minus 6BC, because the 6BC is positive, so goes negative to the other side, equals 2AC, because in this case, the 2AC it's negative, goes positive in the other side. Next, we can take out the V, and it's going to be 4A minus 6C equals 2AC. So the V is multiplying the parentheses, so we can send the parentheses in a division. So it's going to be 4A minus 6C. After that, of course, this one can be an answer because we have already isolated the B. But we can have also another little process for simplification purposes. So let's see. If in the denominator we take out a common factor, it's going to be, we can take out a number 2, and it's going to be 2A minus 6C. We can then eliminate these 2 and these 2 because we have only factors. In this case, for elimination purposes, we need to have only factors. That means we cannot eliminate if we have an addition or a subtraction. We can only eliminate if the terms are multiplying and dividing. That's very important. So in this case, it's going to be V equals AC. I'm sorry, here we made a mistake because it's 3. 2 multiplied by minus 3, it's minus 6, so it's going to be minus 3C. And it's going to be AC over 2A minus 3C. And this is going to be like the most simplified answer we can have. Remember, the idea today is to isolate the variable. So if we do it to this type of answer, it's correct because we have already isolated the variable. But sometimes we will be able to continue the process to simplify it. So it's much better to simplify it to the minimum. But actually, if we are trying to solve an exercise and we isolate the variable like this one, we will get this one and this one correct. Why? Because between the two formulas that are on parentheses, we have equivalent equations. Those two are equivalent equations, and that's why, in this case, both are going to be correct. Let's see another example. So the next exercise, we need to isolate C from the next formula. Maybe you remember this formula because it's the formula for solving a quadratic equation. So in this case, remember, we need to send what is the farthest C first to the other member. So we can send the 2A, it's dividing everything, so it can go to the other side multiplying everything. So it's going to be 2AX equals minus B minus the square root of B squared minus 4AC. After that, what happens? It depends. Maybe we can send this minus to the other side or this minus to the other side. That's up to you. I will send this one because that will mean that already the C is to the left. So it's going to be square root of B squared minus 4AC positive plus 2AX equals minus B. After that, we can send the 2AX that is in an addition as a subtraction to the other side, and it's going to be square root of B squared minus 4AC equals minus B minus 2AX. What happens after that? We need to read off or get off of the square root. It will go to the other side as a power of 2, so it's going to be all that it's on the second member of the equation squared, and that will be equals to B squared minus 4AC. What happens after that? The V squared is positive, so we can send it to the other side as a negative, and it's going to be minus B minus 2AX, all of it squared, minus B squared. So after that, we can continue. What happens? We are missing the minus 4A that it's multiplying the C. So we can now isolate the C, and it's going to be minus B minus 2AX, all of it squared, minus B squared, all of it divided by minus 4A. So that can be an answer. Yes, that can be an answer because we have isolated the C. But what can we do after that? Maybe some people don't like to have a minus sign on the bottom part since it's not usually to have it here. So what can we do? It's maybe we can change the signs of the superior part and also from the inferior part. So maybe we can put it as C equals B squared minus B minus 2AX, all of it squared, and divided over 4A. So maybe we can put it that way to get rid of the minus sign that it's on the bottom. What happens next? Maybe some people can try to do this binomial squared in order to see if we can simplify it. So let's see. In this case, we can set like C equals B squared minus, and it's going to be minus B squared. It's going to be B squared. Then it's going to be 2 times the multiplication of the terms, and after that the second one squared. So it's going to be something like this, all divided over 4A. So what will happen again? It's going to be C equals B squared minus B squared minus 4ABX minus 4A squared X squared, all of it divided over 4A. So B squared and minus B squared, they can disappear. So it's going to be C equals minus 4ABX minus 4A squared X squared over a. So maybe we can continue doing this one. C equals, we can take out a minus 4a, and it's going to be bx minus ax squared over 4a. This 4 with this 4, this a with this a, and we will get as an answer c equals minus bx plus ax squared. And this can be our final answer for this specific exercise. Here, I'm sorry, it's going to be positive because minus multiplied by positive, it's minus. So here it's going to be minus. And the other one, it's going to be also minus. Since in this case, I'm sorry, we take out this minus 4. So it's minus 4a multiplied by ex, it's minus 4a bx. Minus 4a multiplied by plus ax squared, we will get minus 4a squared x squared. And that's why we get as an answer minus bx minus ax squared. So remember, this one can be an answer, yes, because we have already isolated the variable, but sometimes we will need to try to simplify it the most. But don't worry about it, because in this one we have already isolated the variable, so we can solve it if we are trying to do isolating the variable or knowing the specific answer. But sometimes we can continue doing some mathematical process in order to get a more simplified answer, but both of them are correct. Let's see one other example. So let's see, on the next exercise we will isolate d from the next formula. So the idea, remember, we need to move those that are farthest from the letter, then the ones that are closest. So in this case, the bo squared can go to the other side as negative, as minus bo squared equals 2ad. What happens in this case with 2 and with a, I'm sorry, they are multiplying the d. So it's going to be bf squared minus bo squared, or b0 squared is going to be divided by 2a equals d. And remember, normally we put the answer as d equals bf squared minus b0 squared over 2a. And remember, this one is our answer. Normally we put the variable equals all the formula, not the formula equals the variable, but it's the same. So this one was very easy. But remember, for isolating the variable, that's the idea. We need to leave that letter alone. Let's see another example. So the next one is going to be isolate the next one, y1 from the next formula. So we can do it, and it's going to be, I'm sorry, this one is exercise 5. It's going to be, first, the square root can goes to the other side, and it's going to be d squared equals x squared minus x1, all of it squared, plus y2 minus y1, all of it squared. After that, we can send all of this that it's positive as a negative to the other side. So it's going to be d squared minus x2 minus x1, all of it squared, equals y squared minus, I'm sorry, y2 minus y1, all of it squared. After that, this square root must go to the other side. This power of 2 needs to go to the other side as a square root. So it's going to be the square root of d squared minus x squared minus x2, I'm sorry, x1, all of it squared, equals y2 minus y1. So what happens here? There are two possibilities. Somebody can say, okay, I send this one as a negative, but we will get a negative on this side, and after that we can change the signs. Or maybe some of you can say, okay, can I say the y1 to the other side first? yes, of course we can do it, and it's going to be y1 plus the square root of d squared minus x2 minus x1, all of it squared, equals y2. After that, we can send the root to the other side, and it's going to be y1 equals y2 minus the square root of d squared minus x2 minus x1, all of it squared. This one will be our answer. This is very important because sometimes some people can get confused. We have a square root of something that is a square here and a square here. And some people think that they can eliminate the square root with these squared ones. We cannot do it. Let's see why. Imagine we have something like this, and that's why we cannot eliminate it. The square root of, I don't know, maybe 3 squared minus, and it's going to be 5 squared. If we think about it, if you eliminate or try to eliminate this one with this one and this one, it's going to be 3 minus 5, that it's minus 2, right? But what happens if we respect the powers are going to be 9 minus 25, and it's going to be the square root of minus 16. It's not the same, the square root of minus 16 and minus 2. That's why we cannot do this process. That's not correct. If we have an addition or a subtraction inside a square root, we cannot take out the factors. We cannot eliminate the square root. It's the same like when in an term, we cannot send it to the other side, as if it's in the denominator, we cannot send it to the other side multiplying. If we have an addition or a subtraction, it's something very similar. If we have an addition or a subtraction inside a square root, we cannot eliminate the square root and a power of 2. Let's see one last example. So isolate r radius from the next formula, 4/3 of p multiplied by radius, all of it cubed. So what do we need to do here? Maybe we can multiply all the equation by 3 in order to have a whole equation and not fractions, and it's going to be 3p equals 4 pi radius cubic. After that, we can send the 4p that it's multiplying the radius dividing, so it's going to be 3p over 4p equals radius to the third. And remember, we can send a power as a root to the other side, respecting the specific power we have. So in this case, it's going to be cubic root of 3p over 4 pi equals the radius. Remember, in this case, we are not using the process that is called rationalization. We can left the roots on the denominator, but the important part is, remember, our answer must be always the letter equals the formula. So it's going to be r equals the cubic root of 3b over 4 pi. And that's a correct answer. Maybe some people can try to do also sometimes mathematically. Of course, we are not using decimal signs, but maybe some people can multiply 4 times pi, that it's a number, 3 over that number, and that specific number multiplied by b. Of course, somebody can say that's also an answer. But in this case, remember, since we are seeing algebra, we are respecting fractions and not decimal numbers. So this is going to be our actual answer. So that will be it for today's topic, that it's called solving for a variable, or also called isolate the variable. Thank you for listening me. We will see it the next time.